Good morning, everyone. In our first video, I introduced you to three different kinds of reflections which you would encounter in graphs and functions. This morning, I want to cover the first one, which will be a reflection across the x-axis. Remember, in the first video, I mentioned that a reflection is like a mirror image. I'll use a few colors. I'll use red to draw my function, and then I will look and see what a reflection across the x-axis would look like. I'll draw a parabola. Parabola is situated in quadrant 2 on my Cartesian plane. So let's look at what a reflection of this parabola would look like. Reflection is drawn in green. Now I'm going to put in a few sets of coordinates. I'll mark the coordinates in blue. On my function, I will have a coordinate there. And let's call this point A. The coordinates of point A would be -4 and 2. The coordinates on point B would be -2 and 2. So these are the coordinates on my function. Let's call my function the function of f. So let's look at corresponding coordinates on my reflection. These I'm going to call A prime and B prime. Let's look at A prime first. So A prime should be a reflection of point A across my x-axis. I want you to take note of the following. That because it's across the x-axis, my x-coordinate will remain the same, but my corresponding y-coordinate would now change the sign. Instead of being +2 in A, it will now be -2 in A prime. I'm going to do exactly the same for B. So B prime would have the following coordinates: -2 and -2. I want you to take note of the following things which occurs on a reflection. Remember, as I said, my x-coordinates remain the same, but my y-coordinates on my reflection is opposite in sign to the y-coordinates of my function. And that is exactly what a reflection across the x-axis is. Although I've drawn the parabola here, this is the case for any reflection of any function across my x-axis. Remember reflection across my x-axis? My x-coordinates remain unchanged. and my y coordinates have a sign change. So let's have a look and see how this affects any function. Let's look at the following scenario. So let's say I have the graph of f of x. And f of x has the equation three x plus 2. If we had h of x, and h of x represented a reflection across the x-axis, of f, let us find the equation of the reflection represented by h of x. Remember what we've just visualized? That my x values remain unchanged and my y values experience a change in sign. So let's find the equation of my reflected function. So our first step would be to replace y with a negative y to represent the change in sign. But remember that any function is not represented by minus y, it's represented by y, which means we now need to solve for y. Because it's negative y, we need to multiply everything with minus 1. So my reflected function will be y equal to minus 3x minus 2. So which means h of x will now be minus 3x minus 2. Point to remember, reflection across the x-axis, x unchanged, y experiences a sign change. So when we have to do a equation for a reflected graph across the x-axis, use the equation, replace y with minus y, and then solve my equation for plus y.